Hi, my name is Christin and I would love to tell you about the competition I ran on Kaggle. I work for NOAA at the Northeast Fisheries Science Center in Woods Hole, Massachusetts. And this presentation is a little bit different. It's a story that's more technology than science. So, right whales were heavily hunted and continue to face many threats today. They number only in the hundreds. At the Northeast Fisheries Science Center, we conduct aerial surveys to monitor the abundance and distribution of right whales. When we spot right whales, we circle overhead and photograph them. And on a great day, we get a gorgeous photograph like this, an overhead shot of a mother and a calf in clear water that shows the callosity pattern on the top of their heads. After the flight, we then go back to the office and compare our photographs with the New England Aquarium's catalog online to identify the individual right whale in each photograph. The match to the catalog can then be used to obtain demographic information such as lifespan, calving rates, sighting history, residency patterns, and health status. Sometimes identifying whales is super easy, and there are individuals that we can spot from a mile away in an airplane, like Ruffian, who has very distinctive scar patterns. But for whales with very generic callosity patterns, bad photographs, limited sighting records, well, sometimes it can be pretty frustrating. Feeling frustrated with matching whales, one day I took a break to look at some photographs of friends on Facebook. I was immediately greeted by the suggestion that I might want to tag myself in a friend's photo. Well, this got the gears churning for me. Facebook can recognize me. Technology has really come a long way in recent years, and we need something like this for right whales. Hey, that's actually a pretty good idea. But how do I actually do that? I spent some time bouncing the idea around and asking friends and colleagues. I ran the idea past a friend who had just started at Facebook, and she passed it up the chain, but the answer was ultimately no. I tried a similar approach with a colleague at Google, and they didn't exactly say no, but they never really ran with the idea either. I was thinking a lot about this topic at the North Atlantic Right Whale Consortium meeting 2 years ago, and Chris Clark suggested that I check out Kaggle. What is Kaggle? Kaggle is a platform that bridges the gap between data problems and data solutions. Kaggle sponsors data science challenges, and data scientists from all over the world compete to create the best solution. Chris Clark had successfully used Kaggle to improve the classification rates of his algorithms to detect right whale upcalls from the acoustic buoys. The existing models were surpassed within the first few days of the challenge, a really stark illustration of how new methods, perspectives, and technologies can be applied with staggering results. The winning entry increased the researchers' detection model accuracy from 72% to 98%. Well, I was convinced, so I immediately sat down to write an email to the folks at Kaggle. At first, my vision was a bit unrealistic. I wanted to create a software program where I can upload any image of a right whale. A great aerial image, a vessel image, one with a good shot of the head or an okay shot of the head, maybe a great peduncle shot showing obvious scar patterns, and have the software program tell me which whale it is. Sounds good, right? Well, the folks at Kaggle gently broke it to me what they could and could not do. They couldn't create a user-friendly software program, but they could create an algorithm. And one algorithm couldn't possibly match whales from images of different body parts. It really couldn't even match both aerial and vessel shots. Once I came back to Earth and had a more realistic vision, I got to work prepping the data for the competition. We already had a lot of the work done, but there was a little bit of wrangling to get everything organized in the proper format. I ended up providing Kaggle with around 7,000 images that contained a single right whale that we were able to match to the New England Aquarium catalog. About 4,500 of these images were made available for training the algorithm, and the remaining 2,500 were withheld for evaluating the winners. Work sponsored the $10,000 prize pool and gave a free copy of MATLAB software to all data scientists in the competition to highlight the utility of their products in solving challenging image recognition tasks. So this challenge did not cost NOAA a thing. The $10,000 prize pool was broken up into first, second, and third place prize. We launched our competition on August 27th and it ran through January 7th. 364 teams participated in the challenge, comprising 470 players, nearly one for each North Atlantic right whale. The forums were abuzz with activity during the competition, some of which gave me quite a smile, and provided an opportunity for education. Other comments made me kind of nervous, and it became clear that just knowing which part of the photograph contained a whale was a challenge for the algorithm. And then there were a few tweets that just made me smile to think that I'd gotten folks on the other side of the world tweeting about the North Atlantic right. Another thing that really struck me during the competition is the community spirit and extensive code sharing. It was really remarkable to see the way everyone was so excited to tell the world about their latest breakthrough and help each other out as they worked together to solve this problem, even during the competition. Throughout the competition, progress could be measured on the public leaderboard, and on January 7th, the competition ended. Teams had to submit a set of predicted probabilities of which whale was in each image, and I was pretty excited to see the results. The winning solution created by DeepSense.io was able to classify photos to the correct individual 87% of the time. Their solution relied heavily on neural networks. A neural network is a model inspired by the human brain with a system of highly interconnected neurons which exchange information, adapt to inputs, and are capable of learning. DeepSense.io used convolutional neural networks where the individual neurons are tiled in such a way that they respond to overlapping regions in the visual field. They have wide applications in image and video processing and natural language processing. Well, how did they do it? The winning team performed a series of steps to correctly classify images, starting with a head localizer, a head aligner, and then the creation of passport photos. The first step was to locate where in the image was the whale's head. They did this using convolutional neural networks. Step 2 was a head aligner, which also used the convolutional neural networks and essentially created a passport photo of the whale by identifying key points at the top and bottom of the callosity. You can imagine that it would be much easier to recognize individual humans from passport photos than random snapshots at a party. Step 3 was to train the neural networks using these passport photos of the whale. And finally, there was some averaging and tuning performed on the predictions to maximize their accuracy. The winning source code and some trained models are freely available from DeepSense.io on Dropbox. And overall, I was very pleased with the experience of running the Kaggle competition. 364 teams participated. It became clear that the best solutions were based on convolutional neural networks, which is not something that I knew about before the competition. We achieved a percent correct classification score of nearly 90%, and we received the source code. So while overall the competition was a great success, there are still some challenges ahead. The biggest challenge is that now we need to package these algorithms into software so that we can use it. It's currently just a series of algorithms with no GUI interface. I had originally thought that we could probably hack something together easily, but it turns out these algorithms require some pretty serious computing power, and it's a little more complicated than I had first envisioned. Programmers are expensive. So currently we're brainstorming ways to fund moving this algorithm into production, and I would welcome any great ideas.